The if-else statement we learned so far allows you to make true-false branches. And sometimes you want to make more than one branch or two branches. For example, if you have a coin, I give you a coin. This coin can be a cent, a nickel, a dime, or a quarter, or maybe even $50 or $1, right? So these are not true or false. These are what we call the ordinal values, ordinal branches. Ordinal means they have an order. The switch statement will allow you to use an ordinal value to determine how a program will branch. And the switch statement can evaluate an integer or character type variable and make decisions based on the value. The syntax of switch statement is like this: switch, case, and one expression. Expression 1, statement here. Expression 2, statement here. And more cases until the last one is default. If no case is met, then it goes to default. The switch statement will evaluate the switch expression, which can be a byte, short, integer, long, or char. If you are using Java 7, the switch expression can also be a string. If you download your Eclipse from this class, at the beginning of this class, then you're automatically using Java 7. If there is an associated case statement that matches the value, program execution will be transferred to that case statement. Each case statement will have a corresponding case expression that must be unique. And if switch expression matches the case expression, the Java statement between the column and the break statement will be executed. Let's look at a switch statement. Oops. So we have this switch demo where you can see it asks you to input a number, 1, 2, or 3. In case 1, you enter the 1. In case 2, if the number entered is 2, we go to this branch and print out this, you enter 2. And the case 3, you print out, you entered 3. And if the number is not 1 or 2 or 3, it goes to default and will print out that's not 1 or 2 or 3. So the default here is like the else statement, which is a catch-all for the phrase. But default is not necessarily needed. So let's say I run this first, and I'm running with a 4. That's not a 1, 2, or 3. What if I delete this default? It will still run, but it will not give any result. You see that this is terminated without any output. Why? Because there's no default. So Java compare this number with 1, 2, 3 non-matched. So it goes out of this statement without doing anything. Okay, so this is a default. We do see there's a break statement and the case statement. The break statement is optional. If, and this is the tricky part, if a case does not contain the break, then the program will continue into the next case until it runs into a break. So what does that mean? Let's look at no breaks Java. I have a case 1. It's basically the same as enter 1, 2, or 3. I have a case 1 here without the break. I have a case 2 here without the break. So what happened if I enter a case 1? Once it matches 1, it will start running this print out. It will enter the 1. But as it goes down, there is no break. So it will also print out you enter 2. Then it will print out you enter 3 until in the end it will print out that's not 1 or 2 or 3. So if I run this, there's a switch demo. I think I make a mistake and I Let's save it. Oh, I think I made a mistake by oops. I make a mistake by copying things accidentally. So here is the switch demo. Now there's no error. So now let me run this no break, which, as we said, will print, if I enter 1, it will print all of these 4 sentences. And if I enter 2, it will start from here and print out all 3. So let me run with 1 first. You see that? It print out 4. And if I entered 2, it will print out 3 sentences, 2, 3, or 4. Now, if I add a break here, and I run, guess what will happen if I enter 2? So the last one will not be printed out because there is a break here, right? So let's run 2. As you can see, we get a printout for this one because once the number matches 2, it goes here. Print out, you enter 2. Then print out, you enter 3. Then it run into this break and stop the execution. Not stop execution, but finish the execution of this statement and exit. And it goes out here. There's no more statement, so it terminates the program. Now, for this particular case where there's no break, it's like an intentional mistake that is intentionally made, because usually you don't expect people to write code like this without break, and and once there's the entry, it will go through all of these scenarios, right? But this feature that the statement will run until running into a break can be useful when you have multiple cases with the same logic. What does that mean is, like, you have entered a food grade. This A and lowercase a and uppercase a here actually means the same thing, and they should be processed in the same way with the same output, right? So once you get an A or B or C, it should go into the corresponding case. If I entered A, then it will come here and go to the first statement and finish this statement at the first break. Similarly, if I get a C, then it should go here. Either it's a lowercase c or uppercase c, and print out this statement, this sentence, and runs into the first break and finish it. So this feature of keep on running the statements until running into the first break can be useful when you have multiple cases that should result in the same action. You will put this case one by one in line, and eventually it will be running the same code block